So guys, let's try to understand the various notations regarding the multi-layer perceptrons. So there have lot of complex things are happening here. So let's try to first understand the notations first, because to understand the notations will helps us to move further. So because instead of using the graphical structure, lots of time we will be using the notations to understand the concept. So first, it will be better if we just first be clear about that notations, how it's what is its meaning, what are the index significance of that is indexes. Let's try to understand first. So it will be better just if we consider take an examples to understand this concept. So suppose we have a data sets D. On the data sets we have that input xi and corresponding output yi. And let's take this problem is our regression problem. Suppose let's take it's a regression problem. Let's consider. And first let's take the input points belongs to a, for simplicity I have using the 4-dimensional point. Our input point is a 4-dimensional point. For let's take for simplicity. So input, so xi, it's a 4-dimensional point. And it's a, since it's a regression problem, let's take that output is it a real number, since it's a regression problem that I have taken. So since it's a 4-dimensional point, it will be better if we just take a consider here xi as like that. Xi, any random point from our input data sets, is it's look like that. So it's xi1, xi2, xi3 and xi4. So this is our input data point. So now it will be better if we just write the indexes here. So in short, we can write that xi point is like that way. So xi, in short, we can write these things in that way also. Xi j, where j is going from 1 to 4, since it's a 4-dimensional. So these things can be notated as this way. So here, if we just take on that xij, what are the significance of I here and j here? Let's first try to understand this thing. So xij. So first of all, what is here I? Here I, it's denoted that which point it's, suppose if we just take that it's a data set and it's that 4 features we have in that way. If we just try to understand first features, second features, third features, fourth features, and it is the data point, sample data point. Suppose it's the x1, x2, second point, third point, like that way. Suppose xn point. So here I denoted that which point it's it, which point number. So here I denoted the number of point. Okay, and j, what is that? Means that indexes of the j it denotes the feature. So what will be this one? x11, x12, x13, like that way it's 14. So here j denotes that features number. Feature number. Okay, in that way we can write that we can note that things in that way also. Okay, I think you will understand what is that significance of the ij. Now it will be, let's go move further. It will be better just take the plot the things in the way that we have seen in previous video. Sure, let's take it's our input, and that input, how much features we have? We have that 4 features. So xi1, xi2, xi3, 4 features, and this is our input. So now for simplicity, I have taken for the layer 1, suppose let's consider it's the layer 1. It's the layer 1. For this layer 1, I have considered here that 4 hidden neurons are there for this layer 1. three hidden neurons are there. So suppose let's take, I have taken here the three hidden neurons, and let's denote it. I think it okay. I have, it will better just make closer. Let's take, it's the denoted here that if first one is that one first layer number, then what will be the neuron number? First layer, first neuron. Next, first layer, second neuron. Next, first layer, third neuron. Okay. Similarly, if we take that layer 2, similarly, suppose in layer 2, I have considered here the two neurons. Layer number F2, first neuron. Layer number 2, second neuron, like that way. So, if we just make the conclusions of the neurons, then how it's look like? So, in general, if we write a neuron, suppose in general, if we write a neuron Fij, so here, what is the significance of I and what is the significance of J? That is the thing. So here you can see, so I will be the significance of the layer number. It's denoted as the layer number. Layer number. And what is the J significance? J significance here that the neuron number, the neuron number of that particular of the layer I. The neuron number, just don't be confused. I is the layer number and J is that the neuron number of that layer I. That means in simple setting, it's called the index of the neuron. Index of the neuron of layer I. Okay, that's the simple thing. Sure, I think you will understand the thing. Now here again we can consider the output layer. Suppose let's take, we have taken here the output layer. If we taken the output layer, suppose let's take output layer is our F1, and it's that our final output is yi for the input xi. For the input xi, it's that output yi. So this is the simple structure. I think you will understand what is the ij means for the xi, what is that at Fij means, and what is the I significance, J significance. Now let's make the connections first. So after making the connections, how we will index the weight vector for the edge connection? Let's try to understand it first. So suppose I am using the white color for make the connections. So here first of all, we have made that first input to the edge connection. So first input to second, this one. So here first of all, we have to connect, denotate the symbol W for weight and the superscript. Suppose superscript here for which layer this weight is going. So here I am taking here this weight is going to the layer 1. So I will denotate that at 1. Now from where to this neuron is going? So it's going to the from neuron number 1 to the neuron number 1. So it will better in the if we just make that in general for that weight. So here WKIJ, if we denoted that things, so this K here, K denoted that what is the next layer of the particular weight. So what is the next layer of the weight W, sorry, of this weight? Next layer is the layer 1. So if we consider these connections, okay, if we just make that this weight vector, what will be this vector? What will be the next layer? Layer 2. This will be 2. If we just make these connections, then what will be the next layer? W3. If we just make these connections, then what will be the next layer? W3. Here W2. Here W1, W1. Same thing for here, here, here. All the things will be the W1. Okay. Now let's try to understand the what is the I means and what is the J means. Sure. I. Let's take I. I will be what? I will be the from where to which neuron. I denoted the from where it will start the weight, from where it will start the weight, and J will be the from to, means hit in which neuron it will be going. So I will be here from, sorry, it will be the next layer, and I denoted the from which neuron, and J denoted that from to. Okay, let's take the more examples. This connection will be first neuron to the first neuron. These connections will be first neuron to the second neuron. This connection will be first neuron to the third neuron. Similarly, if we just take that, consider this one, let this one, these connections I am going to make. Okay, so these connections, first connections will be next layer 1, layer 1. Okay, from which neuron? Neuron number from neuron number 4. Okay, and from 2 means which neuron? Number of neurons? 1. Similarly, 1 neuron number from 4, which neuron? 2. Similarly, here also 1, it's that 4, it's the 3. Similarly, if we make the connections from here to here, so here what will be this one? W2, and what will be the connections? 2 to 1, W2 next layer, and it will be 2 2. Okay, now let's complete the task, this task. So this is the next layer 2, from which neuron? 1. From 2 neuron number 1. From which neuron? First neuron. From which? 2. Okay, so similarly I think let's complete the next others one also. From let's take this one, third, next layer. Third means that it's output layer, is the third number layer, it's output, or 3, layer number 3 you can take. So 3 number from 2, from which neuron? Neuron index number 1 neuron, second layer neuron 1, from this neuron 1, first only 1 neurons are there. So it is the second number of neurons in neuron index. What is the neuron index? 2, and number of index 1. This is that. So let's take another examples here. So here I have considered these 2, from here to here, here to here, here to here. So let's complete that one. Next layer 1, from index 2, which neuron it's going? 1. Let's 1, next layer 1, which neuron? Number of neurons 2, from where it's going? 2. From 1 to it's going to 3. Similarly, if we just make the connections from here to here, make the connections from here to here, here to here, let's complete it. What will be the what will be this one? So this one will be the from layer number, next layer. What is the next layer? 2, from neuron index, from neuron index. So layer number, neuron index. Layer 1 neuron index is 3, and layer 2 neuron index is what? 1. Similarly, 2 from 3, then it will be 2. Okay, that's one. Let's complete, and one neuron is also raised here. Let's complete it. Just pause that video and complete it and index in yourselves for practicing purpose. Let's complete in yourselves. Okay, the orange color, let's complete it in as yourselves. So I think you will understand what is the significance of that one. Now let's complete that. Everything is okay. So what will be the output of that one? So here output will be what? So here output will be, this is that input that it's coming, and output will be this one. So if we consider this output, suppose I am taking this color. So output, for these neurons, output let's O. So output will be here the previous cell from where it's going. So from the O11. Similarly, its output will be O11. So if you consider this output O, from where it's coming the output, from where it's coming the output from O12. From output O12. Similarly, what will be that one? O13, output O13. So if we just make that conclusions, same notations will be denoted here for output. So here OIJ, if we just consider OIJ, so I index and J index will be the same index for this one. So I will be the number of layer and J will be the number of index of the neuron of layer I. Index layer of index of the neuron I of layer I. Okay, that's the main concept here denoted. The same indexes for that Fij and the Oij will be the same one. Okay, I think you will understand the various notations. Now let's make it simplicity. So first make it simplicity, then we will introduce these notations in the form of a matrix form. Okay, let's try to understand it first. Okay, so make it simplicity. For first here we have, let's take different color, input, then it's that layer 1, layer 2, it's that output layer, and it's that final output here. So here we have only considered the 4 features of a single input. Okay, 4 features: xi1, xi2, i3, xi4. Similarly here we consider here that f11, f12, f13. Similarly for layer 2 we have considered the 2 neurons, f21, f22, and output layer means that layer 3, 3, 1, and it's that final output yi for the input xi. And here how much connections we can build here? How much connections? If we just, for age neuron it's the 3, for age neuron it's going to the 3, this. Similarly here this. Okay, 4. So how much total connections we can build here? So total 4 cross 3, 4 to cross 3, total 12 connections we can make here. Similarly for here, if we just make this one, how much total connections we can make from here? So here we can make total 3 into 2, that is 6. And how much total connections we can build from here? Total 2 and plus 1. So this is the total connections we can make. So these things, this layer 1 weight vectors is called the W1. Suppose in general we have called it is W1. In general we call W2. In general we call W3. Like that, because you can see in the superscript it's 1, 1, 1. Everything, the index is changed, subscript is changed, but superscript is constant. Here also superscript is constant, 2, 2, 2, 2, everywhere 2. So in general, for the layer 1 weight vectors, we denoted it's the W1. For layer 2 weight vectors, we denoted W2. Now, what is the representations of this W1? Let's try to understand it first. W1. W1 first, we have how much input is coming to the W1 and how much output is going. So, for a single features, what will be the output? just if you consider this one for a single features w11, w12, 13, 13, that is for single features over w11, w12, w13. Okay, so for a w11, w12, 13, similarly w1 for a single feature, this is that our okay previous layer. Okay, it will be better if we just make it previous layer number of neuron, and these things will be next layer number of neurons. Similarly here also previous layer second number first neuron, this is the second neuron, this is third neuron. Previous layer how much neuron it has, previous layer 4 neurons it has, so 1 2 3 4, and next layer how much neurons it has, 3 neurons, so it will be 1 2 3. So for that reasons we will take here w21, w1 22, w1 2 3. Similarly here also t1 1 3 2, w1 3 3, w1 4 1, 4 2, 4 3. This is the matrix, and this matrix will represent the w1. So what will be is the size of the matrix? This matrix size is that how much row and how much column? 4 row 3 columns. So this matrix size will be the 4 cross 3. I think you will understand how we will denotate this one. So its dimension will be 4 cross 3. So let's count now the w2. Just pause this video and try to compute in yourselves. Let's. So in previous layer, how much for w2 if we consider this one, for previous layer how much neurons are there? 3 neurons. Let's denote it first, 3 neurons. And next layer how much neurons is there? Next layer 2 neurons are only there, and 2. And this weight vector which is responsible for which layer? Second layer. So we will denote it w2. So let's now fill it. W2 first neuron to the first neuron, w2 first neuron to the second neuron. Similarly w2 second to first, w2 second to second. So w2 third to first, w2 third to second. So this will be 3 cross 2. So what will be the size of this neuron? This will be 3 cross 2. Similarly, if we just make that, similarly if we just make this one w3, previous layer how much neurons are there? 2 neurons are there, and a single neuron for the next layer. So what will be this one? w3 1 1, w3 1 2 1, sorry 2 1, yes, w3 2, w3 2 1. Okay, so this what will be the size of this one? 2 row single column. Yes, so it will be that 2 row single column, and it is after that it will be got that output of that one. So this is the simple vector notation, matrix notations of the edge layer. Instead of confusing these things again and again, I will repeat the thing. Just repeat the video, pause this video, try to understand each notation, because so each time we have not denoted this one. We have just simply using these matrix notations to make the make the operation. Lots of complex operations are there. So instead of a h quantity considering, we will consider these notations. So these notations mean you will consider all the things together in a matrix format. So here we are compute in a matrix way. Okay, not in a scalar way. All the things are computed in a matrix way. So don't be confused. If we just make the notations W1, then you will have to understand. W1 means that this is the collections of this one. Okay, how much neurons are the previous layers have and how much neurons are have the next layer. So it is depend on the there. And ij, what are the significance of I and what are the significance of j? Let's try to repeat again. I means that the from which neuron, from the previous layer which neuron it is, and j means that from the next layer which neuron it is. That's the simple index form and the two. So similarly for that Fij, that Fi means the I denotes the number of layer, which layer is denoted, and J means that in from which index of the neuron. I means that I means the layer number, and J means that on that particular layer, what is the index of the neuron. That's things denoted through the age, and same things also for the J. I means that number of point, which point we will pick up, and J means which features we will pick up. That's the same things. And W and OIJ means the output IJ is the same things of the FIJ. So I means here the number of layers, and J means the index of the neuron particular layer. The same things. Fij, and from the Fij which output it's going, that is the same index from the this cell body. Okay, it's a so simple thing. Just I request you, if you have any confusion, just repeat that video and pause it and see again and again. So don't be confused, because these notations we will take lots of time in our previous computations. Okay, so I think if you just understand in a more clear way, more simplistic way, then it will be better to go further way. So if we have any doubt, any confusion, I request you again, please repeat that video and see, and just try to understand in more simplicity way. And although if you have any confusion, just comment below. I am always here to help you. Okay.